worth holding on to. All right, so when we look at our assignments, just re-emphasizing what you guys are supposed to be trying to knock out. So we have, our Excel assignments, but we also have these homework assignments that you can do. Even if you're having issues with downloading, like in my other class, they're having issues. Just some people are having just issues with downloading the Excel. If you're dealing with Chromebook, you'll have an issue downloading the Excel files. All other computers should be fine, but if you're having issues downloading the Excel files, let me know so we can see if there's some way to help you out there. But you have these section 1.1, section 1.2, and section 1.3 homeworks that you guys can knock out, whether you have access to Excel or not. We're going to talk more about 1.2 and 1.3, but after 1.2 and 1.3, that is the end of chapter 1 as far as content is concerned. The other stuff is Excel work. So we don't have any due dates as of yet, but at some point we are going to put some out there. So make sure that you guys are able to get into Excel and are able to knock these things out. And if you're not, that you get with me so we can see what your issues are, whether it be formulas or whatever the case may be. And like I said, if you don't want to ask in front of the class, that's fine. Make sure you shoot me an email. I know I do have a few emails to answer right now, so maybe you already have. But yeah, so even if you're not able to knock, just want to reiterate or reemphasize, even if you aren't able to knock out the Excel files or the Excel assignments, make sure you work on this section 1.1, 1.2, 1.3 homeworks. And you got a quiz down here as well for chapter 1. So, all right. Any questions on that before we look at a few problems? Any questions on anything before we look at a few problems? All right. Looks like we're okay.
I have a quick question.
Yep.
Is there a way that I can like stay back after your lesson ends and we can talk about like your book and like your My Math and stuff since I just switched?
Yeah, we can do that. And if we run out of time, because I do have a class after this, we can set up another time. So it just depends on how quick we get through this. Like I said, if we can't do it right after this, we can set up another time to talk. It's not a big deal. So we'll make it happen.
Okay, cool. Thank you.
All right, no problem. And was that Torian? Kimberly
Yeah.
Torian? Okay, I was making sure because didn't pop up. All right, cool. So let's go ahead and look at a few problems out of 1.2 and 1.3. Going to pull up the notes I have from 1.3. I'm from the last class, and then we'll erase some things. There's my pen. All right, so 1.2, where we left off with in that section was solving equations. And so let me erase this stuff. And just walk through it. All right, so this section doesn't spend that much time on solving equations. They do expect you to already be comfortable with it. If you have any issues or have any concerns about solving equations, make sure you, once again, shoot me an email. I have plenty of videos with different classes that I talked about solving equations, different lectures that start from the very beginning of solving equations. And if I just need to talk to you about it, then we can set up another Zoom session or something of that nature as far as helping you out. But let me know. But this, like I said, this section doesn't spend much time on talking about it at all. So let's look at a few problems out of here. 2x plus 1 equals 7. If I want to solve for x, my goal is to get x by itself. And we can do that by what I call opposite operations. We want to undo what operations are being done to our variables. Opposite operations, addition and subtraction, they undo each other. Multiplication and division undo each other. When I look at 2x plus 1 equal to 7, the most efficient move to make will be for us to subtract 1 from both sides first. The 1's cancel on the left. That will leave us with 2x equal to 6. And 2x means 2 times x. So if I want to, and I didn't mention this, let me go back. Whenever you subtract 1 from one side of your equation is split up into 2 sides by your equal sign. I didn't mention that. So if you're going to subtract 1 from one side of your equation or the left side of your equal sign, then you must do it from the right side of your equal sign as well in order to keep your equivalency. So that's why I did -1 from both sides of your equal sign. Then if I want to solve for x, or finally solve for x, I will divide by 2 on both sides, and the 2's will cancel, and x is equal to 3.
Can you scoot back up a little bit? I didn't see the. Oh, thank you. Okay, I'm good.
All right. And like I said, just in case anybody missed it, this is about midway through or the latter part of 1.2's homework assignment. All right. Here we have 3y plus 6. 3y plus 6 equal to 2y minus 5. So we note that we have our variable y in 2 different places. So your goal should be to get your y's or your terms with y to one side, your terms without y to the other. We have 4 different terms here, 3y, 6, 2y, and a minus 5. It doesn't matter which term you move first or which side you take it to, as long as you stay correct with your mathematics, you still will get the same answer, get the correct answer, I should say. So I'm going to subtract y, or 2y, excuse me, from both sides. Once again, I want to get all of my terms with y on one side, all of my terms without y to the other side. So 2y minus 2y cancels on the right. 3y minus 2y is 1y. And I notated over here last class, don't forget 1y and y are the same thing. So whenever you see a variable, they assume you know there's a 1 in front of it. So if I have a, they assume you know that's 1a. So that 3y minus 2y is y plus 6. Now to get y by itself, I subtract 6 from both sides. And y is equal to 11. Negative 11. Negative 11. All right. So here, x over 5 plus 3 equal to 7. First move, or the most efficient move to make, would be to subtract 3 from both sides. And that would be x over 5 equal to 4. All right, then from there, we got x divided by 5. So that means we need to multiply by 5 to cancel out the 5 that's attached to the variable. So that'll leave me with just x on the left, and then on the right, we have 20. All right. Let's look at another one. All right, so here we have 6x plus 1 equal to 4x plus 41. Once again, your goal is to get, since I have variables in different places, your goal should be to get x, all of your x terms on one side of the equation, all of your terms without x to the other side. So last time I took the variable to the left, I'm just going to subtract that 2x, 6x from both sides to take it to the right. Like I said, it doesn't matter. I could have took 4x to the left by subtracting 4x on both sides. Just that your goal should be to get all of your terms with x to one side, all of your terms without x to the other. And you're doing that and you're fine. So it's 1 equal to negative 2x plus 41. Then subtract 41 from both sides. It leaves me with negative 40 equal to negative 2x divided by negative 2. X equal to 20. All right, questions? Any questions?
Can you go back to the other problem, like the third one we did? Because I didn't get like the rest of it.
That one?
Yeah. Okay, thank you. I have it now.
All right. Anybody else before we go to the next thing? Oh, this was just something that somebody asked me last class. And so, if you solve down, your goal is to get that variable by itself no matter what's going on. And anything attached to the variable is not good. So you want to get rid of that. So even if it solved down, I had negative a equal to 5, I still need to get rid of that negative. I can do that by taking it to the other side, and a is equal to negative 5. So just talking about, a random, that was just a random question. So, all right, there was one more type of question in chapter or section 1-2 homework. So let me pull that up so you guys can see it. That's 1-3. Let's see. All right, let me go trying to get to the homework. All right, so we're gonna do one. I'm gonna do 16. Somebody asked about 15. I'm gonna show you how 16 is, and that should cover 15 and 17. All right, let me share the screen. All right, so my numbers are a little different. And since I already worked it out, I'll just stick with my numbers, but I want you to see what they're asking of you. Consider a home mortgage of 125,000 at a fixed APR of 4.5% for 25 years. First question is calculate the monthly payment. So let me go to my, just get some, I was reading that, or writing that, I should say. All right. Before I go to the notes, is anybody writing this down? I don't want to turn off the page. Or, all right, I think we're good. Okay. Let's share it. All right, so the formula you're going to use, let me erase these boxes and stuff. Formula you're going to use is this. So payments is going to be equal to P, which is going to be your principal, times your APR, your annual percentage rate, over N. That's the number of times you're going to make a payment. Over 1 minus 1 plus your APR over N, raised to a power. This is an exponent of the number of payments times the years. So in the problem I was doing earlier, my mortgage was 200,000. APR was 4.5%. Don't forget to convert that to a decimal, moving your decimal 2 places to the left before you put it in your formula. So it's 0.045. N is 12 because it's monthly. And then 30 was the number of years that I was going to have this mortgage for. All right. Any questions on that before I scroll up? Okay. So this is how you put it into the calculator. I ran out of room on my right side. I put parentheses over the whole numerator. So I put parentheses over this whole numerator, parentheses over this whole denominator, and with that division sign in the middle. So P is 200,000 times 0.045, which is your APR, divided by N, which is 12. So I put parentheses over that, divided by, start your parentheses again to enclose the denominator. 1 minus 1 plus your APR divided by 12. This is your exponent. This is your exponent function, or button, or symbol, I should say. This caret is your exponent symbol. And then negative N, which is 12 times 30. That's your years. Notice I put parentheses right there to enclose the multiplication of that exponents, those exponents. And then this and this closes out my denominator, parentheses. So if you put it in a calculator like that, you should get this 1013.37 as a monthly payment. Now, if you don't have a calculator that can put it in, that you can put it in like that, then you'll have to follow order of operations, write down some numbers so you can come back to them and so on. So you would do 200,000. You can do 0.045 divided by 12, whatever that number is, times 200,000. Then you will hold that number, save it, write it down, maybe go out 4 or 5 decimal places. Then you would do this. That's in the parentheses. Remember, order of operations, you do your parentheses first. Then you have to multiply this. So you write down this number, write down this number, raise this to this exponent, then subtract it from 1. Write down that number because now that's your denominator. Divide that into your numerator. So basically, you have to go step by step and write down your numbers if you don't have the capability of putting it all in a calculator like this. And you have to follow the order of operations strictly. All right. So questions on that formula, the usage of that formula. If you have questions with your calculator, make sure what you can do is email me a picture of your calculator, and I can walk you through putting it in there, but according to what I see, I just have to be able to see it. And I might need a Zoom call with you, do a Zoom session with you to try to see if I can help you out with the calculator that you have. But that would be an individual thing, not necessarily, a class thing, because everybody does not have your calculator. All right. So B, determine the amount paid over the term of the loan. Okay. So B was determine the amount that you will actually pay over the term of the loan. So the way this is set up, you're going to take your monthly payments, multiply it by 12 for 30 years. So you take the monthly payments that you're going to make, and then you multiply it times 12, and that is going to happen for 30 years. So you multiply all those numbers together, and we got 364,813.20. And like I said, that was B. All right. C says over the total amount paid, what percent, and I wrote that shorthand, what percent is paid towards the principal and what percent is paid towards the interest. So first thing we need to do is establish what the interest is. We were given the principal, which was 200,000. To calculate the interest, we take the amount that we're going to pay totally and subtract the principal from it. And that will be our interest. All right. Then from there, to figure out the percent paid to your principal, you would take that 200,000, place it over that total amount, and divide to find the percent of interest paid. You would take the interest paid and place it over the total amount. Oh, I ain't gonna do that. All right. And I saw in my math lab after I wrote this, I told the class that my math lab wants 54.8, not two decimals, just one decimal. So this would be 45.2. But in all, just make sure you pay attention to the directions. If they decide to ask for three decimals, then you should be able to accommodate whatever it is they're asking of. So make sure you pay attention to the directions. I just know in this problem, they asked for just one decimal. All right, so that's it for 1, 2. Like I said, 15 and 17 should ask you the same type of problems. Let me see. Email about the formulas in Excel. Let me check. Somebody's emailing me. For anybody who may be asking, I do have a few emails that I do need to answer, so I'll try to get to those today. So if I haven't gotten to yours, give me today, and I should be able to answer it. All right. So let's look at, that was the latter part of 1.2. Let's look at 1.3. Do a few on 1.3. Let's see. Okay. Okay, so 1.3 is on homework and tables. I mean, it was on tables and charts. So let's look at Excel before we do this problem. Notice it says rewrite the Excel formula. We have D2 times C5 minus F4 according to the moves they want you to make. And so what do we mean by that? All right. So when you look at Excel, notice if I'm going up or down, I'm looking at these rows and the numbers. So if I go down 2, then I'm changing my number to 11. If I go up 3 from 12, then I'm going to row 9. And then if I'm changing my columns, I'm looking at the letters. So if I'm at G and I go over 2 columns, then I'm looking at changing my letter to I. Or if I go back 3, then my letter goes to F. So once again, if you're going up or down, you're changing your numbers. If you go left or right, you're changing your letters, which would be your columns. So when we go back to the assignment, it says rewrite the Excel formula after the moves have been made. So it says down 3 cells. So if you're going down, then you're changing your numbers. So you have D2 first. Notice they're not really trying to trip you up because they don't have, you're going down 3, then that's going to be D5, but there's no other D5 there. So really, once you establish that first one, that should be right for all of them. So if you go down 3, that's going to be D5. Go down 3 on C5, that should be C8. Go down 3 on F4, that would be F7. So when you're going down or up, all you're doing is are changing the numbers. If you're going right or left, you're changing your letters. So write 2 cells. So you got to, sing the alphabet to yourself or whatever the case may be. If you're going to the right 2, that's E, F, A, B, C, D, E, F. And so you're looking at F2. Then if I take C to the right 2, that's going to be E, and then that'll be H for F. And so that's how you would do that type of assignment. All right, questions on that? All right, so this next one, before we go in there, go back to my notes. We talked about domain and range before. Your first variable is your independent variable. Your second variable is your dependent variable. So you're always looking at these relationships, considering the first one, and then as the first one does something, what happens to the second one? Because the second one that comes in your coordinate depends on the first one. So a mini example I wrote, as I turn the stove knob up or as I increase the stove knob, the heat of the stove should increase. So it's not going to be the other way around. It's always as the first one happens, what happens in the second one. So let's go back to the work. Any questions on that before I leave that, what I said there? Your independent variable is your first one. The second one depends on what happens in the first one. All right, so let's go back to the homework. So it says write a short statement that expresses a possible relationship between the variables. So the size of file, time to download file. So the first one remember your relationship is leaning on the first one happening and the second one depends on it. So the A and B wouldn't be good for us to choose because it's talking about as the time to download does something, but we're dependent on the first one. So it should be C or D. So that's how you eliminate your options. What you want to see mentioned first is the first relationship. So at the first part of the relationship. So as the file size or the size of the file decreases, the time to download decreases or the time to download increases. So we look at situations, the size of the file decreases, time to download decrease. I believe that would be it, but I could be wrong. So let's check it. Yeah. So as your file size decreases, your time to download decreases. But just know that it is possible to get these relationships wrong. That's why they give you a second chance. And of course, you can do an unlimited amount of tries after that problem. Because, sometimes I can get them wrong, depending on, the way you're thinking. Sometimes you're not thinking the way the computer is asking you to think. And so it may take a little getting used to. But just always remember, the first thing you want to analyze or want to be a part of your analyzation is the first part of the relationship. So as the size of the file does something, what does the time to download do? And so that's what we're looking at when you look at those type of problems. All right, so before I go there, the same one. So this one says latitude and then the ocean temperature on a given day. So the first two are eliminated because what we're looking at first is as the latitude does something. So A and B wouldn't be an option for us. So we're looking at C and D. It says as the latitude increases. Not a longitude expert. So as the latitude increases, ocean temperature on a given day, let's say decreases. Yeah, kind of guessed on that one. But sometimes, you may get one that you may guess on, but at least you know how to eliminate options when it comes to these type of problems. Questions. All right, let's look at a few more. Identify the independent and dependent variables, domain and range. So let me go back to here. So your domain, not your domain or range, but your independent is normally your horizontal axis. Dependent is your vertical axis. Remember we talked about this before. And this would be your domain. This would be your range. All right. So whatever is attached to your horizontal axis will be your independent variable. And then what is attached to your vertical axis will be your dependent variable. All right. So let's go back to the problem. All right. So the independent variable is going to be year, because that's what's down on the horizontal axis. Dependent variable will be your population. So then it says domain of the function is going to be the years. Once again, I tell you, remember we said the years, independent, and your horizontal. The minimum value is 1950. Maximum value would be 2000. So we're looking at our horizontal axis. Then the range will be your population minimum value. And notice it says round to the nearest integer. Notice that when we look at our y-axis or vertical axis, that point is close to 2, but it's not there, but it tells us to round to the nearest value or the nearest integer. So we use that 2, and then the other one would be 6. All right. So this section is going to be on tables and charts, and you'll be reading them accordingly. Hold on, did I miss one? Oh, okay. The function, it says B, the function shows a steady increase in population from 1950 to 2000. This one we found out last class would be A, even though A and D are similar. The function shows that the rate of increase in population has been increasing since 1950. So it's kind of similar, but what they really want here should be A. So, and I think it's about being the best way to describe what you see here. The function shows a steady increase in population from 1950 to 2000. All right. I'll do this one more. Like I said, I don't want to do all your homework for you, but trying to show you guys how you should be thinking when you go into these assignments. The data table contains a portion of data points from a function on every daily basis, daily temperature. Okay. All right. So independent variable, your independent variable is at top, which will be your time. And then based on what time of year it is, you will have a certain temperature. So that would be your dependent variable. Your temperature is dependent on the time of year that you're dealing with. The domain here is going to be all days, even though, because when I first did this problem, I thought that it was specific days, January 1st, February 1st, but what gets us here, the keyword is average, the average daily high. So I'm assuming that's what allows it to be all days, because we're talking about the average here. These numbers represent the average. And then the range is from, you look for the smallest value in your temperature to your largest value. So your smallest, I see 36, and then your largest value is 86. Yep. And that should be that. And so from there, you look at the graphs and all the good stuff like that. So, thing about these is that you guys have to try this stuff out. I see some people are getting in there and knocking them out. And some people haven't gotten in there like they should, because you don't want this stuff to get, you don't want to get too far behind as far as these assignments are concerned. Like I said, even if you don't have the the Excel stuff down pat yet, I haven't set a due date for anything, so you still have time, but the time is now to most definitely at least get your section 1112 13 assignments knocked out if you can. And don't forget, you have a quiz down here at the end of this chapter that will be on those things. And then we have to figure out this Excel stuff. If you're having troubles with Excel, make sure you get with me so we can try to make sure you're straight. And because you can see, like, for every one homework assignment, you have 2 or 3 Excel assignments. So you want to give yourself room to knock this stuff out and not be stressed or pressured. So questions, concerns, comments on anything, anybody, before we look to close out, and I'll address individual situations. All right. Okay, I see something in the chat. Okay. Stay back. And I will talk to you and see what's going on with you with Excel. But before I close out with everybody else, any other general questions, concerns before we do so, before we go into the weekend? All right. So once again, we talked about 1, 1, 1, 2, 1, 3 as far as the content, the mathematical content, and just the regular homework assignment work that you can do. So if nothing else, you can go make attempts at that. And then, like I said, let's get this Excel work happening so we can be efficient and proficient moving forward in the class. So if you're done with me, I will see you later. If you have more questions, just make sure you stay back. Outside of that, you guys have a good one. Have a great weekend, and I will see you on Monday. All right. So have an Apple laptop. All right, let me stop the share because I don't need this for a lecture. All right. Echoes.
Hi.
Hey, give me 1 second. Let me answer this email privately. I'm not email, but chat privately, and I'll see what you got. Hold on, he didn't leave, did he? Oh, no, you said it. Okay. All right. All right. So what do we have? You said you had a problem with. So before I go into your Excel work, let me get Miss Torian because she
Okay.
just had general questions just about the class, and then we can look and see what you're having problems with in Excel.
Okay.
So Miss Torian.
Okay, so basically I was in quantitative reasoning
Mm-hmm.
like starting in August or whatever,
Okay.
but my professor didn't speak like great English, so I couldn't understand her at all. So
Mm-hmm.
that's why I contacted the dean to like switch over.